Alright, let's fire this thing up. This is my first time starting it. Hopefully it doesn't blow up. There's going to be 6 BitX gammas being ran off of this one power supply. It's a 300 watt, so there shouldn't be any problems there. Yep, let's see. We got fans spinning. Yep, all the fans are spinning. All the screens are on. These are solo mining fractal Bitcoin. So you guys are probably, some people are wondering what the heck this is. Some people probably already know what it is. Essentially, it's 4 BitX Gamma 601s mounted to this frame here with NoctOct fans. And let's see if this bottom fan is spinning. I'll risk my life and touch yep, it's spinning. So frame here that holds 4 of these BitXs. I have NoctOct fans with adapters, a 120 millimeter NoctOct fan down here on the stand, and yeah, let me know if you guys like this. If you want, I'll give you a little bit of a breakdown of how I did this. So this frame itself here, you can find this on Maker World to download the 3D print file, but it does not come like this. It's pretty heavily modified. A couple of changes that I did to make this work, and essentially it puts everything in a compact space. And also I have one power cable going out to this here. And how I did that was I created channels through here, and each corner has a channel that goes in and it meets right here where I have Wago connectors distributing the power. Also, the 120 millimeter fan here, right here, that's on the base, that pushes air through these channels here to keep the back sides cold. That also comes out the back here as well to kind of keep everything neat. I used 14 gauge barrel connectors, pretty short distance here. I used, to support the load, I used 12 gauge oxygen free copper cable here. And yeah, rounded these edges, kind of made the feet better, easier to screw in. And another thing I did was, if you see this cable running around here on the bottom, I haven't even tested this yet, but I put wrong side, this is the front. So right here, this is a NoctOct fan controller. So if I want to overclock this, I can turn this dial, and now you really feel the air starting to spin. I'll give you a look down there. You can see I put heat sinks on the back of the devices too. And it's a pretty good amount of air, and it's super quiet. My 3D printer is running in the background, so it's kind of probably hard to hear. But it has 5 fans running right here, and I'm super close, so you can barely hear it. It keeps, it should keep the back of the bit axes super cool for overclocking. So I think I'm gonna call this the Octax. No, not the Octax. NoctOct. Yeah, NoctOct, because NoctOct fans, and I think I should be able to overclock this to 8 terahash, especially when I have the air blowing on the back like this. So this cleans up the footprint a lot. You don't have like 4 wires hanging everywhere. I just thought it would be a good idea, and everything seems to be working good so far. Just kind of want to show you guys what it looks like. Oh, and I just created this as a cap, kind of an invisible lid. Everything is running stable. Man, these meanwhile power supplies, for how cheap they are, these are amazing. The fan only turns on when it gets to a certain temperature, powering 6 BitX Gamma 601s right now, and it is not overheating or even getting hot. It will get slightly warm. I've had it run on 6 without this frame here, and the fan turns on maybe once every hour, every 30 minutes, but it's so much cleaner. These two wires are going to the two on the right, but it's just this one single wire that goes into the back. Keeps everything so compact and neat. But yeah, I just thought it was a really cool frame that they had. I did multiple different iterations of it, and this is the one I ended up with that I like the most. I really like how I was able to integrate the cables right through the fins here so it doesn't disturb the airflow as much. And down there, where I routed this power cable through, the fan already has like these legs that come out through the middle. So I kind of, put this 12 gauge wire right above that so it doesn't disturb the airflow that much. All right, so currently we are doing 1.08 terahashes per second at, wow, look at that efficiency, 13.3 joules per terahash. And we are currently sitting at 30.4 degrees Celsius on the ASIC chip, and the voltage regulator temperature is 36 degrees Celsius. The voltage on the ASIC chip is 1.14. Input voltage is 5.1. So we're pretty stable. Let's go ahead and put some overclock in this and see what we can achieve. We'll go ahead and go into the override overclock settings. So we just need to put, I believe it's /OC question mark, or was it / question mark OC? Let's see here. Oh, what am I doing? Oh, give me 1 second here. / question mark OC question mark. No. / question mark OC. Sorry about that. All right. There we go. All right, so let's start off. Let's just go to 825 for the core voltage. Oh, we're at 90% on the fan speed. That's why the temps were so low. Wow, that's amazing, even for being so quiet. Being at 90%, could barely hear it. So we'll leave the voltage the same, and let's see what we are at these settings. We'll let it stabilize. So I did turn up the potentiometer a little bit to get it to that 5.1 volts. Normally the mean wells stock when they come in, they're at 4.9 volts. So we're at 825 megahertz. Our measured ASIC voltage is 1.14 volts. Here we go, we're starting to ramp up. Power is 23.8 watts. Oh, well, yep, definitely this wasn't right. Look at that efficiency, 56.1 joules per terahash. All right, I think we need to up the power a little bit. So let's go from 1150, let's just go to 1250. Save and restart. We'll go back to dashboard. I don't know what's the limit for these bit axes, but I guess as long as the temperatures stay within range, it should be good. So we are expected to get 1.683 terahashes at this setting. Let's see if we even start to hash. We have enough power. There we go. 24.9 watts. Okay, we're getting somewhere. 1.62 terahashes. Our measured ASIC voltage was at 1.24. Look at that efficiency, 15.1 joules per terahash at 1.7. Wow, 14.83. These BM1370 chips are honestly really amazing. I really like them. Super efficient, relatively cheap for us to be able to buy these BitAx Gammas and NerdQ axes at a decent price. Voltage regulated temp is at 52 degrees Celsius. I think we can ramp this up a little bit more. Let's just go, let's do 950. Core voltage, let's just go to 1350. We'll save and restart. I want to really, just get to 2 terahashes. So this whole rig here can be an 8 terahash rig with 4 of these Bidax Gamma 601s on it. I got the fan all the way up, cooling down the back sides of the board. Really feel the air pumping right now. But at the same time, it's super quiet. These NoctOct fans are honestly really amazing. Definitely well worth the money. There we go, 1.89 terahashes per second. Efficiency is still looking good. I know it needs to stabilize, but you get a good idea. There we go, 1.97. We're almost at that 2. You think we'll hit it? Look at that ASIC voltage, 1.34 volts. The voltage regulator temperature is going up slightly, 66 degrees. ASIC temperature staying super low. 1.99. All right, 17 joules per terahash, not bad. 68 degrees Celsius, we're ramping up here. Can we hit that 2 terahashes, 1.93. 69 degrees Celsius, 70 degrees. There we go, 2 terahashes. Nice, just gotta apply these settings to the other ones and it will be officially a 8 terahash rig. Cool thing is, 71 degrees Celsius. Yeah, it is ramping up a little bit. Cool thing is if one of these Bidaxes go out, you just swap it out. You don't have to worry about replacing a super expensive unit. 71, 72 degrees. ASIC temperature staying low. Yeah, seems stable. I'll keep an eye on the voltage regulator temperature, but seems to be stable. There we go, 8 terahash rig. Nice. Let me know what you guys think, and if you want to see the settings, it's 950 on the frequency and 1350 on the core voltage. Alright guys, 34.3 watts. Alright, see you guys in the next video. Peace.